dit vandaag is niet zomaar een laatste sessie, want het gaat hier de hele tijd over in alle kranten, media, over circular plastics en recycling en hoe Nederland ervoor staat. En vandaag hebben we 2 experts die daar graag over met jullie in discussie gaan en hun gedachtegoed daar met jullie delen. Enerzijds Arjan van Vliet, die zal zich zo meteen zelf nog even voorstellen van Shell. En anderzijds Louis Alberto Grau. And because he is born in South America and grew up in Spain, we talk English from now. Give the floor to Arjan and Louis.
Thank you, Irene. You stay there? Yeah, that's fine. Good afternoon. A last session. So only half an hour to go and then you're free. We would like to have a talk about plastic circular economy. Because if this one... yes, it does work. So you all have at least touched some type of plastic today at least 40 times already. Because it is in everything and everybody's life. It is in construction, in transport, in clothing, in healthcare. It's a normal part of everybody's life now. If you want it or not, it's there. And it's actually a fantastic material. It is light, it is versatile, you can use it for a lot of things. And in generally, it's a very safe product. But we've got one issue with it, and that is that at the end of its life, we are not taking care of it. It's a very valuable product, and yet we throw it away. And then what happens with it is globally, a lot of it is not being well managed. A lot ends up in leakage. We don't see that a lot in the Netherlands or even in Europe, but a large part of the world, it's really unmanaged. Landfill, we don't have it as much as more in the Netherlands, which is a good thing. But in certain parts of Europe, there's a lot going in landfill. And this is one of the landfills I came across. It's in Dubai. There are actually 6 of these mountains in Dubai. And I was amazed because I thought there were no mountains in Dubai. And I'm a geologist, so I was a bit surprised to see a mountain. And when I came closer, this is one of the landfills. Of course, we recognize the leakage. And the incineration is what we do a lot in the Netherlands. More than 50% of all the plastic waste that we have is in the incineration. It's a good thing because we get energy out of it and heat. But it's also not a good thing because we're burning valuable products that we can actually use, and it's turned into CO2. So globally, there's 350 million tons of it. And now, this year, it's over 400 million tons of it, of virgin fossil being used. It's humongous. And of course, we need to get from a linear economy to a circular economy. First of all, always go through the R ladder. We need less of it. We need to design it differently. We need to rethink, do we really need to put everything in a wrapper? No, we don't. But for some things, we still need these plastics. And then, of course, use it longer, repair it, and go through the and repurpose it. And then we come to the part of that we need to recycle, recover, and then incinerate. The rest of dumping is a no-go. But we need to move up the ladder. And part of it is that there's still a recycling and recover part of it that is really important. We need to get to less material use, less fossil use, and we need to use the material that is there in the society back into the chain that we can make more new products out of it. I am a major use of mayonnaise. I'm Dutch. My French fries all goes with mayonnaise. Double mayonnaise is the best way to go. And what you see is that it's 100% recyclable. That's awesome. So I used to throw this away in the right bin. And then I started reading on the package, and it says, this packaging is 100% recyclable. And the small letters says after removal of the sleeve. So as a consumer, you also have to do something. Yeah, because in the end, it is made of different types of plastics. Yeah, and they're combined. And if you have different types of plastic together and you throw it in a bin, even in the right bin, most of the times it goes to the incineration. Yeah, only when you do something and keep the different types of plastic separate can be recycled. We've heard before about mechanical recycling, chemical recycling, and even dissolution. But mechanical recycling is what we do now with recycling with plastics. Yeah, and we keep the polymers as one, and we melt it down and use in another product. But hardly or almost never in the same product. Usually we do downscaling or downcycling into a different use of the product. The good thing is it has high yields and low CO2 footprint, but you cannot make everything from it. So with going to chemical recycling, you go back to the original molecules and you can basically make anything from it again. So also the same quality, the same product, and also for food grade and for medical use. Yeah, so it's the same product as from virgin fossil, but it is from plastic waste. In order to do so, yeah, we have the pyrolysis route, but pyrolysis oil itself is not clean enough to make everything from it. And therefore, we have created or built the Market Development Upgrader. This is like a big washing machine for a pyrolysis oil. And with that, we can bring it back to naphtha, and then we can bring it through the cracker, and then we have circular ethylene, propylene, and we can make anything from it again. So this is what goes in. Yeah, pyrolysis oil. This is what we take out, the contaminants, and then this is the clean naphtha type pyrolysis that goes through the machine. But this has been a little journey. And now it is up and running. It's in Shell Moerdijk in the Netherlands, the biggest one in the world, 50 kilotons. And it's father of it, the idea, the scale up, the pilot, all the ideas are here. And that's Louise. So Louise, I would like to take you to the stage so we can go through how did it come that we went from lab to 50 kilotons in one go.
You pass it for me?
Yeah, you can do it yourself. Oh, yeah. There you go.
Very good. Thank you very much. Okay, so let's talk about this application. So first, I want to show how fast this went. In 5 years, we went from the idea and we built not one, but 2 50 KTA plants, one in Singapore and one in Moerdijk. And this is a record for Shell. Normally, you go through research. Only the research takes 15 years at least, while you construct it at least 20 years. But there was a sense of urgency. Hey, we are in this business. We need to be sustainable. Plastic is a huge problem, as has been mentioned, and it's growing exponentially. By 2035, we're going to produce the double of everything is being produced so far. So it's a huge problem. So we say we need to go fast. So how can you go fast in research and construction? We did a lot of the research while we were designing. So still in detail engineering, we were running pilot plants that first we did the first equipment, and we say, okay, we made a design, but then we needed to test the recirculations, the loops, and we needed a more sophisticated plant. I will talk a little bit about that. And that was in parallel to design. I've been 30 years in the oil and this industry and petrochemical, and you never do that because whoever works in projects know that whatever little change you do while you're designing is a snowball. but we say we need to do it fast, and we're gonna. And I'm not a researcher. I'm an engineer. I've been in technology in steam crackers my whole life with 3 of the 5 licensors. So I have a very engineering and practical thing, and I was in charge of the research because the idea came from me and my group in base chemicals, and they let me lead the research, and it was quite a challenge, but it was fantastic. With a great team, but with very practical mind. So that we did it in 5 years. So we wanted to build, first it's extraction process. So we did some tests in just one column, test the different process in one column, but then we needed to recycle the solvent, we need to recycle the water, because otherwise we're doing this for the environment and we're throwing away all the time. We want through solvent and water. It will not be a nice process. So we needed to test the cycles. What will happen if some contaminants accumulates and so. So we say, well, let's build a small mini plan simulating all these recycles. Something simple. At the end, this is how it looks like. It was bigger than like 5 times this, very complex, very difficult to operate, but it was fantastic because we identify a lot of things, problems that later on we'll have. And actually we made some changes even during detail engineering that you will not design like that when you do it from scratch, but to be able to finish the project and to capture the learnings, we implemented changes, and actually it worked. And we're very happy about that because it's whoever works in research and so on. I have colleagues in research that have been 20 years working in 15 projects and none of them materialize, you know. It is normal, it's very difficult. When we start this, the probability of success was 15%, you know. You don't know. Actually, I'm very grateful that they gave me the budget because you don't know how this will work because there's no market. There's no value change about it. So you don't know how much it's going to cost the feed, how much you can sell it. There's a lot of pieces in the whole value chain that we are not involved. So it was a huge risk, okay? So very happy that it materialized into this plant that I go a little bit more in detail. If it let me. Okay, there it goes. So the heart of the process is the solvent extraction. So that's where we started all the experiments. We found out that some of the contaminants accumulates in the solvent. We need a pre-treatment, so we do some caustic treatment, so water wash of the caustic. We get the extraction. We take then in the next column the solvent out of the product, and the other part is the regeneration. So it's a very simple process because it's extraction, a low pressure, low temperature. This is very different from what all the competitors are trying, which also we are trying. There is hydrotreating the pyrolysis oil in order to put it into the steam cracker. But in Shell, we have a lot of experience cracking full range because the pyrolysis oil is a full range from light naphtha to heavy diesel. We can process in our crackers. Most of the crackers in Europe are only naphtha. And also with high olefin content. So that I work in the licensor, we never recommend such a high level of olefinic. But in Shell, we have a lot of experience doing it, even 100% olefinic. We're able to crack it. So this process was perfect for us. And it still is very good for others to use as a first step because you can blend it off with your normal feed. Okay. So I wanted to mention that one of the big work that we did is to understand this oil. This is not fossil fuel. It doesn't look like the hydrocarbon molecules are different. The contaminants that we used in the industry are different. So the first thing you need to understand, what are you putting into your petrochemical plant? What will happen with the hydrocarbons? What will happen with the contaminants? So when you put it in the petrochemical plant, in the steam cracker, you crack all the molecules. And there are models that you know the naphtha, you know the piona, the main characteristics, you put it in, and you know what is going to be your GEOs. Ethylene, propylene, benzene, and butadiene, that are the primary blocks to produce plastic later on. And you need to know how much you're making of each, and where does it go, and how your capacity of the plant will work. But the models we have do not work, because this oil is different. So even to simulate this plant, the simulation models don't work, because the thermodynamic models do not work. So we needed to create new thermodynamic models. We need to tune the models for the cracker. Even to know the contaminants, there were no analytical methods for them, because they are different. So our group create new analytical methods. So this is a huge work being done to be there. So then you know, when you put in the petrochemical plant, where it will end up, how you have to crack it, at what condition, what pressure, what temperature, in which proportion you can mix with your feed. So it's a lot of knowledge you have to get there and recycle. And actually, this plant was started at the end of last year, and it's been running. We're very lucky. First time we run it, it works. Not without problem, a lot of troubleshooting, but it's been very exciting because we have a very positive group. They knew it's a first time. We knew that there will be problems, but they gave us the space to tackle them. And it's been running. So please, go ahead. I cannot tell, that's a commercial thing. But it's running. It's not a full capacity, but it's not a full capacity because we have some mechanical problems with some pumps, but the technology works, and we have tried a full capacity, and it works. It was stopped for some times because we have problems in the steam cracker and we couldn't put it, but right now it is running, you know. Also, the oil supply, pyrolysis oil supply, is a challenge. 7 years ago, we thought it would be a huge market available and no problem. We'll go to the market and buy it. Not the case, you know. In Asia, there's no enough. But here, we have many suppliers, many contracts in the small quantities to be able to, and we are filling it out very fast. So it is working. It's challenging for them, and that's one of the reasons we went to a 50 kTA. I mean, normally your first plan, you go to 5 kTA, 10 kTA. You prove the technology, you try it. If you need to make modifications, it's easier. These are columns of 30 meters tall, you know. The distillation one, the regeneration one, is 2 meters diameter. It's a huge plan, okay? 50 kTA. And the idea was, okay, we need to develop the market. Pyrolysis oil companies is an easy process, but very difficult to operate continuously. So they need to scale up, and they need somebody to consume it. So the idea was, let's bring this unit, hey, here we are, bring your oil, scale up, and run the market. We also were expecting that a lot more competitors will be up to, because there's a lot of hydrotreaters being announced. Savic is one. Hopefully it is running. I haven't heard all the details, but we need everybody to come, because if we don't create a market, it's gonna be very difficult to create the whole change. And at the end, in the future, we want also to the producers of the bottles and so, that they know what contaminants are bad for us, so they can avoid it. Like the example you gave, that is you put the labels and so, that a lot of these colors, for example, the green color, is surrounded, is a ring surrounded by chlorides. Chlorides is one of the big problems in all our units. If they don't put it, fine.
You have one slide, but we are also normally in the interaction.
please.
Yeah, questions?
Any questions?
Yeah, please come
Next,
on stage.
and then,
Okay, who's next? Yeah. There's one slide, I think.
Yeah,
Yeah, I mean, it's
otherwise you get questions on this one.
exactly.
Yeah.
There you go.
Yeah.
Well, but
We'll
I
bring it
already
to
talked about that.
It was in the news and it's up and running. So who is buying our
And we are
circular ethylene
licensing.
propylene?
So the good thing is that they let us, and this idea came from our department up. It was not pushed from up down. We sell it up, and at that time they were willing to invest, and so, and I was very grateful that they put faith on us that this will work. To scale it up, now the environment has changed, but at least if we don't scale it up, they are letting us licensing, and we're working hard to, and we have some clients already interested to build these plants. So, yeah, hopefully this will accelerate, and other technologies also will come. I don't think that the answer will be one technology.
There's a question from Erik.
Kan ik hem vasthouden?
Nee.
Oh. So you produced olefins out of plastic waste. And the pyrolysis oil you import. You don't produce it in the Netherlands or just a little, right?
Well, there's also production in the Netherlands.
But not like a lot.
No, exactly. It's coming all from Europe.
So why don't you use methanol?
Methanol to produce ethylene.
Olefins.
Yeah. From methanol you can produce you can produce olefins, but we have already the ethylene plants that also consumes a lot of energy to get from methanol to. Is easier, more efficient to produce from naphtha in steam crackers.
But
Okay.
it costs a lot of energy to produce the methanol. You can import the methanol more easily than the pyrolysis oil.
No, correct, but you cannot feed the methanol into the steam cracker.
Yeah.
That's a different plant.
Okay, you want to reuse your current assets.
Correct, and use sustainable feedstocks.
This is a subject for you as well. You have a question. I feel that.
Yeah, at first, very impressive how you can do it within a company like Shell in 5 years. It's really into 50 kilotons. It's a big step, I know. I've also been in hydrocracking myself and hydropolysis, so I know the issues. I have a technical question. You don't hydrotreat in this plant, so you remove aromatics and other components.
Correct. So also the extraction remove big part of the aromatics, which for a steam cracker is good.
Yeah. But the fraction you remove,
Yes.
mass balance, how much percentage you remove from your...
It's a fraction that can vary from 5 to 15%, more or less, depends on the quality of the oil and so. And the thing is, this is evolving. Right now, this is a small plant, so we couldn't put a whole plant to do something with it, So we are producing energy right now from it. But actually, from the plant, there are different outlets for that and different qualities. So we think in one is more concentrated, for example, the aromatics. In one is more concentrated in the chlorides. In another is more the diolefins and olefins. So we hope that we continue the research to see in a scale up that is worth it to do something is we can segregate this component and do something more sustainable instead of using for energy.
So you indeed tend to reuse the components you remove.
Correct.
Yeah. The background is we start with biomass waste as a start, and we do not produce any aromatics. We only produce aliphatic, so we don't need your process.
Correct. Perfect. Yeah. Because actually in this pyrolysis is you overcrack then you have a lot of rings, which are not very good. But that's what they used to do to produce fuels and lower the final boiling point. But for this, you want more mild cracking, and then you have higher yields in the pyrolysis plant that we can use because it's a lot more paraffinic. And actually, these paraffins, compared with fossil fuel, in fossil fuel, is you put it to produce ethylene and propylene, the lighter you produce more. But this, it produces is a full range, even heavier, and produce is better yield than naphtha. So it's very, very good.
I suggest you find each other in the drinks. Hey, you have a lot to tell. And here's one question in the back.
Yeah, I was wondering about you are importing the pyrolyzed oil. How do you monitor the contaminants level, taking in consideration that you have made a modeling and the quality of the pyrolyzed suppliers are very different?
Oh yeah, totally, and it's evolving. And the bigger the plants become, they getting more plastic and getting more dirty. So we got, and because we're running from the beginning, we do a lot of analytical. So start analytical at the supplier that have to comply with certain spec. Then when it arrive first in the port of Rotterdam, we have some tanks we also analyze. And when it gets into our tanks, we again analyze because we want to know how to run this unit, at what severity, and so. So we want to understand how the oil is. Hopefully, we're building a model that it will be easier to do simple analytical, like now is done for naphtha, that you analyze on PONA density and so on. You know already what is going to be the yields of ethylene, propylene, and so on. The model in this is not yet, because also this, as you say, it changed a lot, the quality. But we're working on it.
One question here.
Consultancy, when will you have the next plant and what will be the capacity of your next plant?
That's for you.
Yes. Well, we already have it ready. We have the designs ready, although we're going to adjust it slightly to the results of this one. It's going to be 300 KT, which can basically use all plastic waste from the Netherlands. Well, we're only packaging waste. Sorry, food packaging waste already. We're only going to build it if the full value chain is there, when the market is there. Yeah. So we're asking a lot from the buyers, because we're asking, okay, give us large volumes for a long period. Yeah. 10 KT for 10 years. Now we get small volumes, 2 KT for 2 years. I say, no. They're also testing the market. So only when there's sufficient market, when there's stability on supply, if there is enough pyrolysis oil, and basically when we have stable also regulations that actually make us happen this.
Thank you.
So actually it was a quite risk to build this plant and that big without being the market there, the regulation is not there. Is to make that investment, and it will work or not. I mean, it was a big step to do that nowadays, in today's environment, it will be very difficult. So I'm very happy that we did it. So we hope that more companies will come, the regulation will be there, and they push the whole market.
But the plot besides the cracker is already ready.
Actually, part of the plant was already built for the 300 KTA.
Thanks, Louis en Arjan, for your presentation.
Thank you.
Ik ga even over in het Nederlands.